I'm going to show how to make this spiral pattern using Affinity Photo's Procedural Texture Filter. To get started, I'm going to start with a new document. I'm going to set it to 1024 by 1024 pixels. And I'm going to make sure it's in RGB mode, create that. I'm going to select the Fill tool, and fill this with black, choose the Move tool, and then add a live filter and choose procedural texture. I'll start with a single equation and a single real custom input. I'll set that to 1, and I'll assign this to all 3 channels. I'm going to be making an Archimedean spiral which has the form in polar coordinates r, the radius, is equal to a constant times the angle theta. So to get started, I'll start with the variable v, coordinate system, vec2, rx, ry, times a divided by w. To get the radius, I'll just take variable rd equals the length of v. I'm using the function arctangent 2, and so I thought I'd describe sort of how that works. So if you remember from trigonometry, the tangent of a triangle is equal to the opposite over the adjacent. So if I have this angle right here, the yellow part would be the opposite side, so that's sort of the distance in y, and then the adjacent side would be the distance in x. And so I take the distance in y divided by the distance in x, and that's the tangent of this angle. To create the spiral, we need to do sort of the opposite. We know the position x and y of our vector, and we want to compute the angle from that. In mathematics, the angle is usually measured in the positive direction when you're going from the x-axis and moving counterclockwise. So as I go from the x-axis and move up this way, 0 to 90 degrees, that's called the first quadrant. The second quadrant goes from 90 degrees to 180 degrees, and then I could keep going this way, or I could go the other way. I could start here at 0 and go to minus 90, and then from minus 90 to minus 180 degrees. If you're using radians, it'd be pi over 2, pi, and then minus pi over 2 and minus pi, going in the other direction. Now, if I want to calculate the angle based on these two distances, I run into a problem when I have dx and dy down here in the third quadrant. And that is that these are both negative, but I'm taking the ratio of y over x. So the problem is, in the first quadrant, when I have a positive dy and a positive dx, when I take this ratio, I can't tell the difference between the first quadrant and the third quadrant, because minus dy over minus dx, the negatives cancel, and it's equal to dy over dx. In the second and fourth quadrants, I have a similar problem where I can't distinguish between dy over minus dx and minus dy over dx. In order to resolve this, some applications provide 2 different arctangent functions. You can have one that's just y over x, and that returns an angle in the range from minus 90 to 90 degrees. There's a restriction on this that x should not be equal to 0. The second function is atan 2. In this case, you provide 2 inputs, y and x. That way I can distinguish between those problems that we have with the different quadrants. In this case, you can return an angle between minus 180 degrees and 180 degrees, so the full 360 degree range. The only thing is that you can't have both y and x equal to 0. So to compute the angle theta, I'm going to use the function atan 2. That way I can give it an x and y component. So I'm going to put in v dot y and v dot x. So I have the radius is equal to the length of v, and then the angle theta is the atan 2 of v dot y, v dot x. The next part of this is to calculate the spiral, and so I'm just going to have the radius plus the angle theta. And I can see it has a very narrow space there. So one of the things when I bring back this angle, it's going from minus 180 to 180. So that's a very small distance. This is like 1 degree of arc. It goes from 0 to 1. So to stretch that out a little bit, I'm going to divide by 180 degrees. And there I can see that now it's sort of curving up, and it's starting to look a little bit like a spiral. It has sort of a black and gray look to it. Now I'd like to be able to control this a little bit, so I'm going to put in a couple of real number values so I can adjust this. So I'll put in a b value on the angle and then a c value on the radius. Now for a while I was stuck at this point. It sort of loops back around and then stops on this line right here. And then I finally thought, well, what if I put this inside of an oscillator and see what happens then. So I'm putting an OSC on the inside of this, and there I have the spiral. So to make this a little smoother, I'm going to make it an oscsc, and there's a nice smooth spiral. And now I can zoom out with this one, and I can also increase the number of spirals by changing this one. Now what does this B do now? So I'm going to check that. So each time I increase this by 1, I add another spiral arm. So this is the overall scale of it. This is the spiral arms. And then this one will be the size of the spiral. I'm going to add a gradient map to this, and I'm going to choose this one. If you want the colors for this, the first one is FE218B. The second one is hex FED700. The third color is 21B0FE. I'm going to drag this down so it's inside of here. So here's the formula I have so far. I have vec2 standard coordinate vector, then I have the length of the radius, and then the angle, theta, and then I have the spiral portion of this. I just add the radius and the angle to get the spiral. So this formula is creating values that are going higher and higher, and it doesn't take them long before they get greater than 1. This function then sort of wraps those around back and forth every time they go above 1, and sort of keeps it always in the range from 0 to 1. Now another thing I could do with this is I could set it up so that I can get a bunch of spirals on here. I'm going to change this first coordinate system to V0, sort of a basic coordinate system, and then I'm going to create a new coordinate system, VAR V equals the fraction of V0. So I'm going to take the fractional part of that number, so every time it goes bigger than 1 or bigger than a whole number, I'm going to throw away the whole number part of all those numbers, so it'll always range from 0 to 1. And then I'm going to subtract off 0.5, and that will center, put the center of each thing in the middle of the screen. And I'm going to bring this down to 1, or to 2. Now if I look here, it's sort of distorted, it's not in the middle, but if I move this over far enough until it gets into the positive range here, now it's repeating. So now when I bring up the scale, instead of it just changing in size, it's adding more repeating patterns. And so this one now has a different effect. Another thing I can do is I could add a -1 to 1 slider. I'll just call it D for direction. And I can change the direction of this if I multiply my radius component times D. So right now it's just set to 0, so I can swing it that way, or I can reverse it by going this way. Another thing I can do as I bring the spiral arms down, I can now go all the way to 0, and then I just have this sort of target-shaped pattern. I could also add a angle offset. I'll just call it pH for phi, and then this is the angle. I want to divide it by 180 degrees, so I'll just put parentheses around the atangent 2 function, and then I'll just add my angle phi within there, and then I'll divide it by the 180 degrees too. And that way I can have these shifted around, so I can have these spin around when I move this phi offset around like that. So some other things you can do in this case, I added a quantize function around the whole thing so that I could change so I can sort of quantize it and give it more of a striped effect. In this case, I added an oscillator to it to give it this wobbly effect. And then in this one, I multiplied it by an oscillator to give it sort of this extreme wavy effect. So that's how you can make an Archimedean spiral using Affinity Photo's procedural texture filter. Let me know if you have any comments or questions, and thanks for watching.